Hello everybody and welcome back. In this video we're going to look at topic 2, lesson 4. We're looking at a concept first and then we're going to look at the next example. So let's talk about what a complex conjugate is. I know in the last video I had mentioned the idea of complex conjugates, but I didn't go into grave detail. This one might not either, considering time limits of videos and such. So let's talk about this. All right, so a complex conjugate comes about when you need to basically kind of rid your complex number of the imaginary components. So we will see this when we have to rationalize the denominator. Complex conjugates are based off of the idea of difference of squares. So if we looked at the beginning of this lesson of x squared minus 16, and I talked about how you could actually make these into factors of x plus 4, x minus 4, and this was the difference of squares because you have two squares and you're taking the difference of them. The complex conjugate is basically the same idea, except you're having real and imaginary components to your number. So in this case, we have some value a, which let's pick a number 3, and then we have some value b. I'm going to say this is 2. B is part of the imaginary, so I'm going to put the I to denote that 2 is part of the imaginary part of the number, and 3 is the real part of the number. All right, for a complex conjugate, you're going to just rewrite it again. The only difference between factor A and factor B is factor A is going to be a plus and factor B is going to be a minus. So complex conjugates are complex numbers with equivalent real parts. Basically, I have the equivalent of 3 and the opposite imaginary parts. So the opposites here are these plus and the minus. All right, so if we had this, what's going to happen is like this, when I FOILed it out, we got two terms. We got x squared, or this guy right here, squared, and we got 16 squared, which is the second term squared. Oh, sorry, not 16 squared, 4 squared, which is 16, which is that second term squared. And so looking at this, my first term is 3. Before we had x squared, so I'm going to do 3 squared. Okay, now we have the second term. We're always going to subtract it because a positive times a negative will always be a negative. But I'm going to square this guy, 2i squared. And what I get is 9 minus 4i squared. Now we talked about what I squared was. I squared is going to be negative 1. Negative 1 times negative will give us a positive. So this is 9 plus 1 equals 10. Now, not all your problems are going to be like this. Some of your multiplication problems might be a complex conjugate. Most of them probably will not be. You will have a middle term. You should be able to identify what a complex conjugate looks like, and that you can easily just square the two terms in it. So let me show you an example of where complex conjugates are primarily used. Gotta go down to simplifying quotients. All right, so let me grab this guy, example 4 in your book. Bam, it's right there. All right, so example 4, simplify a quotient with a complex number. How can you write the quotient 10 divided by 2 minus I in the a plus bi form? I'm going to guess that this is not an I. I don't think that's an I. I'm going to refer back to my book just to make sure. I didn't see that before. It just kind of popped up. So just looking in the book right now. Yeah, that I is not supposed to be there. I think it's just remnants. All right. So what I'm going to look at, I'm going to do 10 times 2 minus I. Now, the idea here is if I multiply by 1, then I still have the same number. But I could make 1 anything. I could make 1 5 divided by 5 because 5 divided by 5 is 1. Or I can make 1 7 divided by 7 because this is still 1. Or because what we want to do is we want to basically what's called rationalize the denominator. We want to get any imaginaries, any square roots, which an imaginary is the square root of -1. We want to get that out of the denominator. So this is where I want to use that complex conjugate. So really, I can multiply this by 2 plus I. And notice if I had a 7 in the denominator, I had to have a 7 in the numerator because that 7 over 7 equals 1. So I'm going to put this in the numerator too. In other words, I'll be doing 10 divided by 2 minus the imaginary times 2 plus the imaginary divided by 2 plus the imaginary. Okay, again, right here in the denominator, we have a complex conjugate. And what's going to happen here is when I multiply it going across, I could do 2 times 2, which is 4. The middle terms are going to fall out because you're going to have a plus middle term and a minus the exact same middle term. So that's going to be a 0. And then you're going to have minus I squared. And the numerator, I'm going to keep it as 10 times 2 plus I. The whole reason I'm going to do this is because I'm going to see if the denominator can simplify that numerator. But if I distribute that in, that's one more step I have to deal with in the end. All right, again, I squared is going to be -1. -1 times negative is a positive, so we are left with +1. So we have 4 plus 1, 10, 2 plus I. 4 plus 1, that's going to be 5. Simplify. So then I have 2 times 2 plus I. Now I could simplify this even more. So I have 4 plus 2I. And that is my answer for this problem. All right. So write each of the quotient in a plus bi form. You have this guy, and we are done. So make sure that you finish these up. If you have any questions, again, that complex conjugate, you're going to do 2 plus 6i. This one is, we're looking at the term of the 2i, so this -1 will stay the -1. This is the one that should probably change. So again, ask questions if you need them, and we will see you in the next video.